In this video, we examine the degeneracies that arise in a three-dimensional box due to high symmetry. For a general three-dimensional rectangular box, the stationary state wave functions are psi of nx and y and nz as a function of x, y, and z equals to the square root of 8 over abc times the sine of nx pi x over a times the sine of ny pi y over b and times the sine of nz pi z over c. A, b, and c are the edge lengths of the box, and nx, ny, and nz are the quantum numbers associated with the x, y, and z coordinates. The three quantum numbers are independent, and each of them is a positive integer, 1, 2, 3, and so on. The total energies for these stationary states are E of nx and y and nz equals to h squared over 8m times nx squared over a squared plus ny squared over b squared plus nz squared over c squared. Let's look at a special highly symmetric case, the cubic box. For such a box, the three edges are of identical length, that is, A equals B equals C. The energy expression simplifies. We get E of n of x, n of y, n of z equals h squared over 8ma squared times nx squared plus ny squared plus nz squared. Let's plot an energy level diagram for the associated stationary states. Let's plot the energy in units of h squared over 8ma squared. If all the three quantum numbers are equal to 1, the sum of squares in the energy expression equals 3. Therefore, the ground state has an energy of 3 h squared over 8ma squared. This is the 0-point energy. If the quantum numbers are 2, 1, 1 or 1, 2, 1 or 1, 1, 2, the sum of squares equals 6, and the energy of all these three states is identical. It's equals 6 times h squared over 8ma squared. Such states that are distinct but have the same energy are called degenerate. The degeneracy of this energy level is 3 because there are 3 states. The degeneracy of the ground state was 1 because there was only one state with that energy. Next, we get 3 states where the sum of squares of quantum numbers equals 9. These states are given by the quantum numbers 2, 2, 1, 1, 2, 2, and 2, 1, 2. This group of states has a degeneracy of 3. The next higher lying group of degenerate states is 3, 1, 1, 1, 3, 1, and 1, 1, 3. These have a total energy of 11. Next comes a state that has no degenerate companion. It has an energy of 12, and its quantum numbers are 2, 2, 2. So it has a degeneracy of 1, as opposed to 3 for the lower 3 groups of states. Next, there are a total of 6 states that have an energy of 14. This continues, and there are many more states of various degeneracies, some of them with degeneracy of 9 and higher. So we see that there is a high level of degeneracy among the states of the cubic box. This is because the box is highly symmetric. Indeed, this is a general principle. The higher the symmetry, the higher the degeneracy. When the symmetry is lowered or removed, the degeneracies are reduced or vanish. You can always determine the degree of degeneracy by looking at the energy expression for the specific box and by finding all the combinations of quantum numbers that yield the same overall energy.